So if we're given an equation and we're not in factored form, then here's the answer. We just factor it. That's what we do. Here, let me show you how this thing works. If I were to say, all right, x squared minus 2x minus 15. This is a quadratic equation in standard form. I'm venturing to say that the factored form is this: x plus 3, x minus 5. I'll show you how to get that. In fact, that's what we're going to be covering for the next, chapter. But let me prove to you at least that this factored form is the same as the standard form. I'm going to FOIL out this factored form. So that would be x squared, because I'm doing first, outer, inner, last, minus 5x plus 3x minus 15. So that would be x squared minus 2x minus 15. Look, these are the same thing. All right, let's see. Recall that factoring is the opposite of multiplying. Exactly. Factoring is like dividing something, whereas FOILing is like multiplying. When an expression is written in factored form, then the primary operation, the last in all of your operations, is multiplication. So factoring, that turns an addition expression into a multiplication expression. But how do we do this? The remainder of this handout explores common types of factoring. Okay, all right, yeah. So check this out. I'm going to show you a few techniques. Let's take a look real quickly. All right. So the first type of factoring is, I guess it's like reverse distributing. Let me remind you what distributing is all about. Just delete that. Here we go. All right. If I were to give you this problem, distribute this 5x squared times 3x plus 4, you would multiply in the 5x squared into here, and you would also multiply that 5x squared into here, because this 5x squared is being multiplied by that parentheses. So you need to make sure that this stuff on the outside meets everything inside of that parentheses. So that would become 15x cubed, because 5 times 3 is 15, and x squared times x is 3 of them, x cubed, plus 20x squared. Now, when I'm asking you to pull out or to factor this, one of the things you will want to check first is there a common number that you can pull out of both of these? And the answer is yeah, I can pull a 5 out of both of these. And by pulling out, I mean dividing out. So I can pull a 5 out of this, and I go 5 times 3x cubed plus 4x squared. And is there a common amount of x's that I can take out? Well, the most amount of x's that I can take out is 2 of them, because I can't take out 3 x's like x cubed, because there's only 2 of them here. So I can pull out 2 x's out of here and 2 x's out of here, and I'll have 5x squared times 3x plus 4. So if I were to give you this problem, then I ask you to factor it, this is how you would do it. All right, let's try a few of these. Let me get some room. I'm going to erase some stuff over here. All right, let's go with this. And 7x minus 21. All right, 7x minus 21. Is there a number that I can pull out of both of these? The answer is 7. I can pull 7 out of 7, and I can pull 7 out of 21. Again, I mean dividing. So if I divide 7 out of here, so I have 7 times, divide 7 out of here, I'm just left with 1. So it's just 1x, also known as x. And if I divide 7 out of here, oh, the minus is still there, by the way. Divide 7 out of here, I get 3. These two expressions are the same thing. See, if I were to unfactor it or distribute the 7 back in, I would get what I have above. Distribute the 7 here and distribute the 7 there, I would get 7x minus 21. So this is the factored form of that equation. All right, let's try this one. Let's do 3. 8x to the 5th power minus 12x cubed. Okay. Is there a number? What is the biggest number I can pull out of 8 and 12? Because I could pull out 2. Okay. I could pull out a 2 and I go 2 times 4x5 minus 6x cubed. But then what I would have to do is pull out another 2 because I'm not done. There's a number that can be pulled out of both the 4 and the 6. So I'm going to try to pull out the greatest common factor, and I would say that's 4. So if I pull out a 4, then I'll have 2x to the 5th power minus 3x to the cubed. Now what I'm going to do is I'm going to pull out the greatest amount of x's I have. I have x times x times x times x times x over here, and I have x times x times x over here. I got 5 of them in the first one, and I got 3 of them in the second one. What's the most amount I can take out of there? I can pull out only 3, because this one has 3 to spare. This one only has 3 to spare. So I'm going to go 4x cubed times 2x squared, because I pulled out 3 out of here, minus 3. So this right here is the factored form of this. Let's try a hard one right here. That one does look hard. Let's do it. 7x cubed y minus 5z to the 5th power plus 3x squared z squared. Ooh, ew. Okay. Is there a number I can pull out of all 3 of these terms? See, 1, 2, 3 terms. Is there a number that is in common with all 3 of them? And I would say no. No, there isn't a number that I can pull out of all 3 of these. I can't think of any number that divides into 7, 5, and 3 nicely. All right, what about x's? Is there at least one x that I can pull out of all of them? Well, there's one here, or there's at least one there. But there's none here, and there's 2 here. Oh, okay. So I can't pull out any x's because all 3 terms don't have x's in common. What about y's? Well, there's no y over here, so again, y is out. What about z's then? Okay, well, there's a z here and a z here, but there isn't one in this first term. So I can't pull out a z either. So I'll be honest with you, this equation right here is as factored as it gets. I mean, I know it's ugly, and you can't pull something out, but not everything can be factored. I think I'm going to try one more. Let's try this one. 48 x7 y squared minus 36 x cubed y. Alright, let's deal with the letters first this time. Actually, let's deal with all of them. I can pull out at least 3 x's. X cubed. I can pull out at least one y. There's the y. Now for 48 and 36, I think that I can pull out an 8, right? 8, 16, 24, 36. Yeah, okay, alright. Alright, I think that would work. So this would be, if I pulled 48, or if I pulled 8 out of here, 9, 27. Okay, wait. Actually, wait, I can't pull out an 8, can I? I think I can pull out a 4. And this would be, alright, so if I pulled out a 4 out of here, this would be 12. I pulled out 3 x's, so I'm left with 4 of them left. And I pulled out 1 y, so I'm left with 1 y left over. Alright, and then I got that minus sign, okay? And then I pulled 4 out, right? So that would be 9. And this would be, I pulled 3 x's out, so that's correct. And I pulled out 1 y, so there's nothing there left over. Oh, I guess I could have pulled out something even bigger than just 4. I could have pulled out 12. And I know that because, look, the numbers, I can still pull out something. I can still pull out a 3 out of there. So I've got 4x cubed y times 3. And then if I pull 3 out of here, I get 4x 4y minus 3. At this point, I need to be done with this. But what I'm saying is 4 times 3, that's 12. I didn't think about it at the time, but you could, the biggest number you can pull out of both 48 and 36 is 12. because 12 times 3 is 36 and 12 times 4 is 48. So this would be my answer.